Hey chemistry students, this is Mrs. Miller. Today I want to give you an option of a different way of understanding and solving titration problems. So you probably would have already gone through the notes with Mr. Roloff. He runs through one way of solving these titration problems, but I'm going to give you option 2 today. As I already mentioned in the previous video, Mr. Roloff talked about one way of solving titration problems. While there's nothing wrong with that way of solving those titration problems, I actually choose to solve my titration problems a little bit different. In my opinion, I think Mr. Roloff's method has a few more chances for you guys to get errors, to get lost in the math. So I'm going to use a really easy, concrete type of equation that I think is a little bit easier. So the second method that we can use is called the titration formula, where we're going to use this. M acid, V acid equals M base, V base. So what does that mean? Well, it means the molarity or the concentration of the acid multiplied by the volume of the acid, it could be in milliliters or liters, is equal to the molarity or concentration of the base times the volume of the base. So again, it could be in milliliters or liters, and our molarities are going to be measured in capital M, which is molarity or moles per liter. The reason why I like this method is because you can skip some steps. So in this type of a formula, what you can do is you can keep your volume in milliliters, which we weren't able to do as long as both answers are in milliliters, because milliliters cancel out. If you're more comfortable working with liters, in order to go from milliliters to liters, you can see here that you're just going to divide by 1,000. The other thing that's cool is you only have to convert volume if the unit for volume for acid does not match that of the base. So let's say for one you have something in liters, and then in the other you have it in milliliters. You'd have to convert one of those. But pretty much on every problem you guys are going to be working with, they're already going to be in the same type of format. So they're either both going to be already in liters or both already in milliliters. The other thing you need to know is you need to balance that chemical equation to figure out what the mole ratio is going to be. It's that mole ratio that with these types of problems can get really, really tricky. So when I look, remember, if I want to compare CH4 to O2, I only have one CH4 and I have two O2s. So understanding that ratio is going to be really important to figure out which version of this equation you're going to use. A lot of times when we do titrations, you're going to end up with 1-to-1 mole ratios, meaning that the coefficient out in front is going to be 1. So there's 4 simple steps for solving these types of titration equations. The first step is to balance your chemical equation. So when I look here, it says NaOH plus HCl yields H2O plus NaCl. So when I start looking, 1, 1, I have 1 O, 1 O, 2 H's, 2 H's, 1 Cl, 1 Cl, perfect. So all of these are 1s. The next step is you want to identify the variables for the acid and for the base. So for this, you are really just looking at the reactants. Okay, remember the reactants are on the left-hand side. And when I look at this, acids tend to have an H in them, and bases tend to have an OH in them. So if I look, I see my H out front. HCl has to be my acid, and that means the OH that I see here, this has to be the base. Okay, so that's going to be important as you figure that stuff out as well. Then what we're going to do is we're going to be able to plug into our equation exactly as it is. So the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And then all we're going to do is rearrange the equation to solve for the missing variable. So let's do an example. The example that we have here is what is the molarity of 27.5 milliliters of HCl solution that requires 33 milliliters of 3.5 molar NaOH. Okay, so our first step that we want to do is we want to balance this chemical equation. This is the same one that was on the previous page, so I know it's going to be 1, 1, 1, 1. The next thing that I want to do is I want to identify my acid and my base. So I did that on the previous one as well. So this is my acid, and this is my base. And now I want to go ahead and I'm going to identify my variables. So when I do this, I need the molarity of the acid, and I need the volume of the acid, I need the molarity of the base, and I need the volume of the base. So as I start looking through this, it says, what is the molarity of 27.5 milliliters of HCl? HCl is an acid, so I know that that's my volume. So 27.5 milliliters. That is required for 33 milliliters of 3.5 molar NaOH. I know that NaOH is my base, so this goes for the base. So my volume is 33.0 milliliters. My molarity is 3.5 molar, and I don't know the molarity of the acid. So my next step then is I want to plug this into my equation. So I know the equation is Ma times Va equals Mb times Vb. Go ahead, plug those in. I don't know Ma, so I'm going to leave it alone. This is 27.5 milliliters, 3.5 molar, and 33 milliliters. Okay, now what I want to do is I want to rearrange so Ma is by itself. So I'm going to divide both sides by 27.5 milliliters. This cancels. And now I'm left with Ma equals 3.5 molar times 33 milliliters divided by 27.5 milliliters. And when I plug that into my equation, Ma is going to be equal to 4.2 molar. And again, we're dealing with the HCl. So that's how you're going to solve that one. What you're going to find is that it's not always a 1-to-1 ratio. So what happens is we have slightly different steps when we don't have that 1-to-1 mole ratio. So we still are going to start the same. We still want to balance our chemical equation. So here's our new chemical equation, H2SO4 plus KOH yields H2O plus K2SO4. So when I go to balance this one, I see 2 H's here plus another. Okay, that's not good because that one is even. I see 1 SO4, 1 SO4. That's good. 1K, 2K. So I'm going to balance that guy out. So now I have 2 Ks. I have 2 O's, but only 1 O there. So I'll fix that. And now I have a total of 2 H's here, 2 H's here, so 4 and 4. So now I'm balanced. So this ends up being 1, 2, 2, 1. Okay. Next up, identify the variables for the acid and for the base. So again, acids are going to tend to have an H on them. So this is my acid, and this is going to be my base. And now I'm going to be using a different equation because of the mole ratio. We have a 1 to 2. We have to take care of that. So the equation is very similar. Still going to be Ma times Va equals Mb times Vb. But we also have to divide by the mole ratios of each. So it's going to be Ma times Va divided by moles of A equals Mb times Vb divided by moles of B. That's why it's so important to balance your chemical equation first. Then you're going to go ahead and rearrange. So here's the practice problem we're going to be working with. What we see is calculate how many milliliters of 1.5 molar KOH would be necessary to titrate 47.8 milliliters of 1.67 molar H2SO4. So step 1, we want to balance this. This is the exact same problem from the previous slide. So we know that this is 1, 2, 1, 2. The next thing that we want to do is we want to identify the acid and the base. And we are going to go ahead and we are going to plug these values in. So we're going to go Ma, Va, and then I'm also going to do moles A. Then I'm going to do Mb, Vb, and moles B. So as I start looking, so it says 1.5 molar KOH. We know that KOH is our base, so this is going to be 1.5 molar. We know that we're titrating 47.8 milliliters of 1.67 molar H2SO4. That's going to be our acid, so my Va is 47.8 milliliters. 1.67 moles, or molar, sorry. Now I need the moles of A and the moles of B. That's just the coefficient out front. So I have 1 mole for A, I have 2 mole for B, so I'm looking for VB. I know my equation is still going to be MAVA over mole A equals MBVB over mole B. And now what I'm going to do is I'm just going to plug these values in. So I'm going to go 1.67 molar times 47.8 milliliters over 1 mole equals 1.5 molar times VB, because that's the one we're looking for, over 2 mole. So we want to get VB all by itself. So in order to do that, we're going to have to rearrange our equation. We want to get the 2 moles on the other side. It's being divided now, so we're going to multiply it. So we're going to multiply both sides by 2 moles. So I'm going to put that on top. And we have 1.5 being multiplied, so we're going to divide it. So then we're going to divide by 1.5 moles. Oops, this just goes on the bottom. And now what I'm going to do is I'm going to plug this into my calculator. I'm going to go 2 times 1.67 times 47.8 divided by 1 times 1.5, or just by 1.5. And that's going to give me VB is equal to 106.4 milliliters KOH. So you have that one additional step of doing the moles, like mole A and mole B, when you do not have a 1-to-1 mole ratio. So feel free to use whichever version of this you like. If you guys have any questions, as always, let us know. Have a great day.